Hi friends, here in this video I'll be explaining the problem on pipe bend. So let's get started. Now here is the question in front of us. Whatever is given here, I'll write that in the form of data first. It is given a 0.4 meter into 0.3 meter 90-degree vertical bend. So when this cross section is given, it indicates the diameter of the pipe bend, that is at inlet and exit. I'll write it in the data. First, I'll mention the type of bend here. It is a vertical bend. As the cross section is given 0.4 into 0.3 meter. So 0.4 would be indicating the inlet diameter D1. 0.3 would indicate the diameter at exit. So from these diameter values, we can make out that it is a reducing bend, that is the diameter goes on reducing towards the exit. Then after getting the diameter, I'll calculate the area for section 1 and section 2. So area 1 comes out to be, it is 125.66 into 10 raised to minus 3 meter square. And since this is a circular pipe, and then D2, with that I'll calculate A2, and the answer is 70.69 into 10 raised to minus 3 meter square. So from the diameters, the area has been calculated and it is a 90-degree vertical bend. Then carries 0.5 meter cube per second oil. So this 0.5 meter cube per second is nothing but the discharge. Discharge is indicated by capital Q and it is 0.5 meter cube per second. Then it is carrying an oil of specific gravity 0.85. So the specific gravity of oil is given, that is denoted by S. It is 0.85. So from this I'll get the density of oil, which is the specific gravity of oil, that is 0.85 into 1000, which is the density of water considered as the standard liquid. So here this value comes out to be 850 kg per meter cube, which is the density of the oil which is flowing through this pipe bend. Then next it is given with a pressure of 118 kilonewton per meter square at inlet to the bend. So at inlet, since the pressure is given, that would be indicated by P1. So P1 is 118 kilonewton per meter square, and that would be, if I convert it into Newton per meter square, so multiplying with 1000, that is 10 raised to 3 Newton per meter square. So P1 is given. Then the volume of the bend is 0.1 meter cube. So the volume is given, denoted by V for the bend. Next, find the magnitude and direction of force on the bend. So we have to find out the magnitude of the force, and that would be called as the resultant force which is acting on the bend, and its direction, that would be denoted by, I'll write it as phi, that is the direction where the resultant force is acting on the bend. Then it is also given, neglect the frictional losses, so we don't have to consider the forces due to friction or the head loss due to friction. Assume both inlet and outlet to be at the same horizontal level. So another condition is given, that inlet and exit, they are at same horizontal level, and also assume that the water enters the bend at 45 degree to horizontal. It means the bend is of 90 degree and the water is not entering horizontally, but it is entering at an angle of 45 degree. So roughly, if I can explain, if it is a 90 degree bend, like I'm just showing it with the help of a line diagram, that here we have a 90 degree bend indicated with the help of a line. So if the condition was not given that water is entering at 45 degree, I would have taken the water entering horizontally. But here in this problem, they have said that the water is entering at an angle of 45 degree. It means we have to keep the inlet as inclined. And the water should enter at an angle of 45 degree with respect to the horizontal. So that can be shown as the inlet, and here I can get the exit. And the orientation can also be in such a way, since the water is entering at 45 degree, we can also have a pipe bend in this way, like I can show it in this way as well, that it is entering at 45 degree to the horizontal. Here the angle is 45 degree, and the water is entering from here, that is from top to bottom, and leaving or exiting at this end. So we can draw the bend either in this condition or this condition. We cannot use the condition here because in this first condition the water is entering horizontally, but they have said that water should enter at 45 degree. So now into the solution part. First I'll draw the diagram of the bend. Now into the solution part. So here there is a horizontal line, and this inclination is 45 degree with respect to the horizontal. And here, as it is a 90 degree bend, so here we have 90 degree angle, and again this angle would be of 45 degree. So 45, 45, 90. Then the water is entering at 45 degree angle, so that would be indicated that along this same line of stroke the water is entering. Now it is entering with a pressure force of P1, that is pressure at inlet, and area 1. So P1 into A1 gives me the pressure force at inlet. And now since it is inclined at 45 degree angle to the horizontal, so P1 A1 gets divided into two components. One is the horizontal component, another is the vertical component. The horizontal component is P1 A1 cos 45, and the vertical component is P1 A1 sin 45. So that is the pressure force at inlet. Next, there is inlet velocity, and that inlet velocity would also have the same direction indicated by V1 since it is at section 1. Here I'll write down that this is section first, and here we have section second. In the problem they had also mentioned that both the section 1 and section 2 are at the same horizontal level, so I have shown them on the same horizontal level. Now velocity V1 is also inclined at 45 degree with respect to the horizontal, as we can see here. So this velocity component also gets divided into two components. One is the horizontal component, so this will be V1 cos 45 degree, and the vertical component of velocity, since the pipe is inclined, so we are getting two components. This would be V1 sin 45 degree. Then at the exit there should be a pressure force in the opposite direction, because when there is pressure difference then only the flow is possible. So I have to show a pressure force at exit but in the opposite sense. So this is the pressure force P2A2 at exit. Now this is also inclined at 45 degrees, so it will have two components. One is the horizontal component, which is P2A2 cos 45, since we are measuring the angle with respect to horizontal, and here the vertical component will be P2A2 sin 45 degree. Then the velocity. Now pressure force has to be in the opposite direction, as we can see here, but velocity would be in the same direction when the flow is happening, because velocity, the water or the oil we have, the liquid would be flowing in this direction, but it is flowing due to the pressure difference. So then pressure forces are to be opposite, but velocity should be in the same direction. So here the velocity at section 2 would also be inclined. This velocity is v2 in section 2nd. Now this is also inclined at an angle of 45 degree to the horizontal. So here there is the inclination of 45 degree, and the velocity component is v2 cos 45 degree, since angle is measured with respect to horizontal, and the vertical component will be v2 sin 45 degree. So once I have shown all the pressure forces and the velocity, only one thing remains here, that is the weight of the bend. And since the weight of the bend is given, it would be acting from the CG. I am just showing it over here, and through this section the weight of the bend is acting in the downward direction, indicated by capital W. Now why I have taken the weight of the bend? For that, in the question they have given the volume of the bend. So whenever the volume of the bend is given, we have to consider the weight of the bend or the weight of the liquid which is flowing in the bend. So therefore here I'll write down a small hint here regarding this same case. So whenever the volume of the bend is given, that same amount of volume will be there for the liquid which is flowing in the bend. So we have to consider the weight of the liquid when the volume is given. In this case it is given. Now how to get the values of the resultant forces? For that I would be using Newton's second law of motion. And how we are getting those different forces? By using the Newton's second law of motion. For that you all can refer my video, whose link would be provided in the description of this video. So you all can refer, where I had explained in detail how those forces are calculated, or we arrive at that forces by using the Newton's second law of motion. Now quickly here also I'll explain. I'll say that let Fx be the component So here I have defined two components. Fx is the component of resultant force exerted by the oil on the bend in the horizontal direction, and I have taken positive direction. That is, when Fx is acting towards right, it is considered as positive. So the assumption is I have taken rightward direction as positive for the horizontal component. Similarly, for the vertical component of resultant force exerted by the oil on the bend, I have taken upward direction as positive, so that is Fy. Basically I need to calculate Fx and Fy in order to get the resultant. Now after that I'll say that as per Newton's second law of motion, which says that the summation of all external forces in the direction of flow is equal to the mass into acceleration, and therefore acceleration can be written as final velocity minus initial velocity divided by time. So here this mass is having a unit of kg, so when I divide it by time, that is m by t, it becomes mass flow rate, that is m dot, which is kg per second, into v minus u. So m dot into v is called as the final momentum, minus m dot into u is called as the initial momentum. So basically the equation which I'll use is summation of all external forces in the direction of flow is equal to mass flow rate into the final velocity minus initial velocity, and this mass flow rate can also be replaced by density into discharge. Why? Because density is having a unit of kg per meter cube, discharge is meter cube per second, so meter cube gets cancelled, so kg per second is the unit of mass flow rate. So replacing mass flow rate with density into discharge. So first I'll calculate for the x direction. So I'll be using this general equation. Now going into the bend diagram, we have to write first of all the forces here onto the left hand side. So starting with Fx, the component which I have defined, Fx, then here we can see there is a pressure force P1A1, because at first we have to see only the horizontal components. So P1A1 cos 45 acting towards right, so it is positive. The next pressure force is P2A2 cos 45, which is acting towards left, so leftward forces are treated as negative, so it is minus P2A2 cos 45. So these are the pressure forces which are present, and Fx is the component which we have to find out. Apart from that, we don't have any other horizontal forces. Velocities are there, but it would be there onto the right hand side. So next, and here I'll quickly write the convention. Rightward forces, I have taken them as positive and leftward forces as negative. So it is equal to rho q. V is the final velocity, and final velocity along x direction, that has been resolved. So final velocity is v2, and it is the component v2 cos 45, because we are considering horizontal direction. So it is acting towards right, so positive, so that is v2 cos 45 degree minus initial velocity along x direction. Initial velocity along x is v1 cos 45, and again it is acting towards right, so positive. So therefore here is an equation from which Fx can be calculated, and remember, whenever you are solving the problem related to pipe bend, we have to develop the formula on the spot like we have developed in this case. So therefore I can say that Fx would be equal to, here we have rho q P1A1 cos 45, when it goes onto the other side it becomes negative. Similarly, when P2A2 cos 45, which is negative, goes onto the right hand side, that would be positive. So I'll write them. Now this is the general equation from which I'll get the value of Fx, that is the horizontal component of force acting on the bend. And keeping this as the first equation. Now the similar approach would be used for the vertical component of force. That is the summation of all external forces along y direction is equal to rho q into v minus u. And for the y direction or the vertical direction, the convention is upward forces are to be treated as positive, or the upward direction is positive and the downward direction is negative. So therefore first I'll write down Fy, the component which we had defined, and that is positive. Next, when we look into the diagram, there is P1A1 sin 45 acting upward, so positive, the component of vertical force. Next, we have P2A2 sin 45 again, which is acting upward, so positive. Now, apart from the pressure forces, since in this problem the volume of the bend is given, so weight needs to be considered, and weight is also a force. It is acting in the downward direction, so negative, and it would be onto the left hand side, so minus the weight of the component. So these are the forces which are acting on the bend in the vertical direction. Onto the right hand side we have rho q. The final velocity along the vertical direction, we can say it is V2 sine 45 and it is acting downward, so it has to be negative. So minus V2 sine 45 degree, then again minus the initial velocity along y. So initial velocity along y was V1 sine 45 acting upward, so positive. So here we have V1 sine 45 degree, and this is not negative. Here in the formula itself we have a negative sign, so that we have to take care of. Finally, I want Fy, so shifting all the terms onto the other side, and for that the equation would be so here I have shifted all the terms onto the right hand side because Fy is what we have to calculate here. So P1A1 sine 45 when it goes onto the right hand side becomes negative. Similarly P2A2 sine 45 and W which is negative would become positive onto the right hand side. So here is equation second. Now looking into equation 1 and 2, we can see that there are various unknown values like velocity V1, V2, pressure P2 and even the weight of the liquid or oil as given in this case. So I have to find all these unknowns. So starting with velocity V1 and V2, for that I would be using the continuity equation. So after this, since from the continuity equation discharge capital Q is equal to A1 V1 and that is equal to A2 V2, that's the continuity equation, that is discharge remains constant. So therefore V1 would be Q upon area 1. Discharge is given in the question, it is 0.5 meter cube per second. Area 1 we had calculated, it was 125.66, 10 raised to minus 3. So from this V1 value comes out to be, it is 3.978 meter per second. So that's the velocity V1. So now after getting V1, similarly I'll calculate V2. It would be Q2 upon A2. Discharge is same. Area 2 was 70.69, 10 raised to minus 3. So from this V2 value comes out to be the answer which I have, it is 7.07 meter per second. Now after getting V1 and V2, the next thing is we have to find the value of pressure P2 because P1 is given. For that I would be using the Bernoulli's equation applying at section 1 and 2 of the pipeline, that is at section 1 and section 2. So therefore when we apply the Bernoulli's equation, it is written in this way. Now since it is given in the problem that the losses are to be neglected or the frictional losses are to be neglected, so I am not adding the head loss due to friction here. So the Bernoulli's equation is P1 upon rho g, which is pressure head at inlet, V1 square by 2g, kinetic head or velocity head at inlet, Z1 is the datum head or potential head at inlet, similarly at the exit. Now this is the general Bernoulli's equation. They have mentioned in the question that the pipes are at equal level, that is at the same horizontal level. So we can clearly see that since they are at the same level, their heights with respect to a common datum Z1 and Z2 both are same. So Z1, Z2 will get cancelled out because they are at the same level and we need P2. So for that I'll write the equation in this way, that therefore P2 P1 upon rho g goes on to the other side, so that gets subtracted. P2 minus P1 upon rho g, the common denominator, is equal to, here we have V1 square by 2g, so V2 square by 2g would be shifted, having the same denominator, so we can take them common, and since Z1 Z2 are same, they have been cancelled. Now we know all the values here. I'll quickly put the values and get the answer of P2. The density of the oil, it is 850, already calculated in the data. And we can also see that G and G will get cancelled out from both the sides. So from this, when I calculate these terms, the P2 value comes out to be it is 103.47 into 10 raised to 3 Newton per meter square. Now after getting P2 value, the next unknown which I need to find here is the weight of the oil, and that has to be calculated from the volume of the bend. So I can say that we know the relation that since weight density of any liquid is equal to weight of that liquid, denoted by capital W, upon the volume of that liquid. So therefore basically what we mean here is weight is equal to weight density into volume, and weight density is the mass density into acceleration due to gravity and into volume, that is by definition. So therefore the density, the liquid here is oil having density of 850 kg per meter cube, G is 9.81, and V is indicating the volume of the bend, and the volume of the bend mentioned in the problem is it is 0.1 meter cube. So from this, when I calculate the weight of oil comes out to be, it is 834 Newton. Now even the weight value is known, so all the unknowns are there with us, so those values have been calculated. So first I'll put the value in equation 1 in order to get fx, and then systematically I'll put the value in equation 2 to get fy. So here is the equation in which we have found out all the values. So therefore putting all values in equation first, on the left hand side we have fx is equal to, here there is density into discharge, density is 850 for the given oil, discharge is 0.5 into the bracket, it is V2 cos 45 minus V1 cos 45, so I'll put the value of V2 and V1. Next minus, it is P1 A1 cos 45, so putting the value of P1 and A1. At last we have plus P2 A2 cos 45, so putting the value of P2 and A2, P2 we have just now calculated, so it is 103.47 into 10 raised to 3 Newton per meter square, area to 70.69 into 10 raised to minus 3 cos 45. So when we calculate this entire portion, the answer of fx comes out to be, it is minus 4.38 into 10 raised to 3 Newton, or in other words that becomes 4.38 kilonewton when I divide it by 1000, and since it is minus, it means fx is acting towards the left hand side, because at the start the assumption was fx was towards the right hand side. The answer is negative, it means it has to be towards the left hand side. Similarly, I'll put all the values in equation 2 to get fy. Now Fy was equal to, again, rho Q, then minus V2 sine 45 minus, it is V1 sine 45 minus P1A1 sine 45. I'll put the values. Next, minus P2A2 sine 45 plus W, and W was 834 Newton. So on calculating, I am getting the answer of Fy as minus 18.14 into 10 raised to 3 Newton, which can also be written as 18.14 kilonewton. And here also, since the answer is negative, it means the component of vertical force is acting in the downward direction, because we had assumed upward direction to be positive. So that is Fy. After that, I can get the resultant force. So therefore the magnitude since it is involving the two components, that is Fx and Fy, the formula of magnitude of resultant is root of Fx square plus Fy square. So I'll just put the value of Fx and Fy to get the resultant. Fx is 4.38 kilonewton square plus Fy 18.14. So from this, the resultant force comes out to be 18.66 kilonewton. So that's the first answer. Now I need to find the location where this resultant force is acting. So therefore the location of resultant force given by phi is equal to tan inverse mod of Fy upon Fx. See, instead of phi, we can also use the notation as theta, that is for the location of the resultant force. Now therefore, here we have a mod sign where we have to put only the positive values. Fy 18.14, Fx 4.38. So therefore the location is at 76.42 degree with respect to horizontal. And that's the second answer. Now I would be locating this resultant by drawing an axis system. So here we have positive x-axis, negative x-axis, similarly positive y and negative y. Now the value of Fx came out to be negative, so it is towards this negative side horizontally. Similarly Fy was negative, so it is in this downward direction. It means the resultant would be there in the third quadrant, because Fx and Fy both are negative, and the angle is 76.42 with respect to the horizontal. So the inclination of the resultant is proportionately, we can show this angle, which is phi is equal to 76.42 degree. And this is the direction for the resultant force, which is 18.66 kilonewton. It means at this direction, the resultant force would be acting on the bend, which is the vertical bend given. So the resultant would be somewhere here into the third quadrant. And now this resultant indicates the force exerted by the oil on the bend. If we want to calculate how much is the force exerted by the bend on the oil, for that we have to go exactly opposite, that is into the first quadrant, having the same inclination. with respect to horizontal, which is phi equal to 76.42 degree, and here this force is indicating the force exerted by the bend on the oil. So in both the ways we can calculate, that is the force exerted by the oil on the bend and by the bend on the oil, it means it is a reaction force, and since both would be equal, they would cancel each other, and hence the bend would be in the equilibrium. So in short, that was a problem regarding a pipe bend. At the end, if you'll find my videos helpful, you can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.